Hey, hello there, and welcome back to another video. So this is still Advent of Code, day 22. The infamous cube walking problem. So, okay, I'm going to continue as we left this thing yesterday. So what we had done was we were able to do one transition from one face of the cube to another, and I had a little cutting of the unfolded cube that I was given in the input. I marked the different faces here, like maybe the camera will capture, like up, right, front, down, and so on. And this thing can be folded into a cube, of course, as you would expect. And the transition that we coded yesterday was when going from the up face into the back face. And basically, if we have the input, where's this? This one here is the up face. When we go up here, we appear in this face, which is the back face of the cube. Maybe I can increment size a little bit. This is the up face. We go up from here, and we appear in this face from the left, from over here. So that's what we implemented here in this very ugly code. And I left a reminder for myself that I would like to convert this match to return just what is the new face and what is the rotation that we need to do. So yeah, we'll keep a mental note on that. But let's run. Well, that's a Wordle command, cargo run. So yes, went from face up to back, from this position to this position, and then it panicked, saying, hey, I don't know how to go from face back to in direction 0, 1, which is down. So it seems like we have walked a little bit on this face, and now we are exiting from the bottom. So maybe we could code that and like that special case, and then try to see, you know, what's the pattern here. So what we were doing here, there is something that I wanted to remember when, yeah, here when we calculate the new x, we are doing this thing, the face x and, well, face y, and this this addition is actually unnecessary because we know y is 0 because we were in row 0 and we went up. So I will leave this as a comment, not as an optimization, but as a comment to remind me, okay, this is the calculation that I need to do. This is unnecessary, but you know, this is kind of the pattern, kind of ish. Because yeah, I would like to express this thing, this matching, this match statement as succinctly as possible. This should probably end up being, as I made the annotation, like we go from this face going up, like to what face and how to rotate things, or maybe even like to what face and what is the new direction in that face, because here we have this, like we know if we went up, we appear right. And probably that's probably that's probably also symmetrical in a way. Like if we are in face B and we go left, we're going to appear on the top side of the up face going down. So it's like reversed in an interesting way. We'll see if we get to if we need to implement that case. So I think this print statement is quite generic. We can maybe move it here because I want to always know, okay, when I did a phase change, and I can maybe say position went from this to this, and also would like to do that with direction. Direction went from the x, the y. I haven't updated this yet, right? Yeah, no, these are immutable. It went to new dx and new dy. New phase. Why don't you like this? Oh, because this is in here. Well, maybe I can put it outside. Let me do the new phase is phase, and here I can assign this maybe. Okay, so we should have that printing. Oh, you didn't like that. Ooh. Why though? It's never used. But wait, it's used here. What are you talking about? This is after the match. That seems like a weird message that this thing is not used because we are using it here. We are printing. And we are... Well, anyway. We're doing that, and maybe I would like to have more printing. I would like to maybe either print these instructions that we are processing so that we can like follow along manually on the map here, or even maybe print the map and do the actual tracing to understand what the hell we are doing. That could be fun. Let's try to implement that actually. I have no idea. I'm surprised that Rust is like warning about this. It's never read. Maybe it's overridden before. Yes, okay, it's overridden. Yeah, but what would you like to do with this? Like, I don't know. Somebody. Like, yeah, this assignment is never used because it is right in this case. We are always like, this is the only branch that doesn't panic. So this, you can probably assume that this is always taken. But well, I need to assign it to something. I think I cannot leave it like this, or do I? Oh, look at that. Can I do this? Oh, this is amazing. So today I learned something new, very new about Rust for me, which is that you can say, hey, let this thing be, do not assign it to anything, and then if all the execution paths assigned this thing, then we are happy. And it doesn't complain about uninitialized memory, and that is really nice. That warning actually made a lot of sense. Thanks, Rust. So okay, let's do the fun thing about printing the map. So we are in part 2. what we are going to do is probably something, let's do something sort of simple. Here we're going to print line, processing instruction, and just print this instruction, which of course is going to complain because it will need to be debug, drive debug. Well, let's see with that printing. Yes, 56. This is, yeah, debug prints. Oh, look at that. We have walked quite a bit in the back phase, it seems. So maybe we went to other phases and then we came back and then we are exiting in this direction down. So yeah, printing the map makes a lot of sense then. Instead of trying to follow these instructions manually in the map, let's just print it. So how to print the map with markings of where we were? I think one thing that we could do is maybe these tiles, like if it's open, maybe I can put like an optional mark here, and the mark will be like a character, right? And if when we are walking around, we can put that character on the map. The map would need to be immutable, but that could work. But I think I would maybe prefer to just put this on another data structure. So mark is not the exact word that I want. I know the word. It is breadcrumbs. That is what I want. We are going to be leaving breadcrumbs along the way. This is going to be a hash map from position to character, or maybe to direction. And when we print it, we know what to do. So yeah, hash map new. And of course, this will need to be imported. I don't know if I imported from the correct place. And yeah, it did. Okay, so we are going to leave some breadcrumbs. When we are advancing, this is what will change our actual XY coordinates. So before changing direction, let's leave a breadcrumb. Breadcrumbs inserts. So into XY. Last time that we were at XY, we were going in dx dy direction. All right, that was easy enough. We have marked our path, and then okay, we have this processing. We can, after processing the instructions, we can print map, and we're gonna pass the map that we get and the breadcrumbs. And generate this. Map is what is this? What? Didn't I have yeah, an alias for this? I probably want to have an alias for these points at some point, but let's leave it like this for now. So how are we going to print the map? Well, for each line or row in map, and then do I want to collect into a string? Maybe I want. So say let line be row iter. So map is a vector, or the row is a vector of tiles. So we're gonna have this and say, well, map this to characters, and then we're going to collect these things into a string, and then we're just going to print that line, and that will be it for this code. So here we receive a tile, and then let's say let's character be, well, match these tiles, match tile. Sorry, can you? Yes, I like this. So if it is empty, it's gonna be the empty space. If it's open, it's a dot, although maybe there we have to do the breadcrumb check, and if it's a wall, just be a wall. So yeah, here I guess we can say, hey, if there's a breadcrumb on this xy, but we need to know which xy we are talking about, so we'll have to enumerate this. So it's gonna be y row, and iter enumerates, and we are gonna receive x and tile. And we can say, hey, if it's open, let's put the wall over there. If it's open, if there is some dx dy in breadcrumbs, we're gonna get the breadcrumb from x and y. If there is something, then we are gonna print like a marker, else we're gonna print an empty dot. And I guess let's leave the marker for now, like b, or the breadcrumb, say, well, a b for breadcrumb, or something that I can distinguish, a big old 0. Then we can maybe use these directions. So you're complaining here because you expected a reference. Sure, take it. You don't like this because, of course, as I32, and that's it. Are you happy with this? No. Oh, print map doesn't have a return type because it doesn't return anything. We are printing these lines. Let's say that we don't use this for now. And let's also do a print line. Okay, let's run actually on the big terminal, cargo run 22. Woohoo! Oh, look at that! we have something. That's really cute. That's really nice. So, okay. it seems like we were going down this way. We turned right here, then left. I'm saying right here because we are going down. Then we turned left, right, and we tried to advance. We only advanced 5, it seems. Let's see. Here, we turned right. Before that, did we advance? No, it says advance 33. But, are we marking this correctly? Interesting. Maybe I can also mark the current XY. So let's mark X I32 and Y I32. This will be actually currents X and current Y. You are complaining about this because I don't know why you're complaining. Let's pass here X and Y. Oh, actually, I'm putting that in the wrong position. It's inside of the hash map type parameters. Okay. So if it is the current one, we're just gonna say, hey, if we can do that here. If xy is equal to per x and per y, then return x. Why don't you like this? Mismatch, yeah, of course. Actually, we can probably do this marking also here. Like, also if there is a breadcrumb, just early return, and otherwise have this simple mapping here. Okay, let's run this thing again. Okay, we are here. Okay, that's why we weren't seeing this. We are standing here, and I guess it's weird to me that we didn't like put a breadcrumb on that position. So when we do this, we update the thing. Oh, maybe the breadcrumb, I need to put it like afterwards. I don't think this will make a difference now that we are marking the X position, but okay, we are here. The last instruction that we processed correctly was turn right. So we are here, we are turning right, and we then are facing down, and then it says advance 17. Okay, so we have to go down that way. That was a nice helping with like that printing was a nice help. So we are in the back face, and we are going down this back face. So also have in this printing or cutting of paper, I have the up direction of the faces to like know, okay, this is the up direction in 2D. So if I make the cube and I go down the back face, I know that I'm appearing on the right face up. So you can see maybe there, the back face going down is the rotation of camera also is the right face on the top. So, okay, that's interesting. We're going down here and we are appearing on the top right here. And the position of this, we are near the right over here, right? Yeah, we are more near to the right than to the left. If I think about this in this piece of paper, we also appear like we are going out in this position. We also appear in the right face, this face, kind of to the right position. Okay, so let's copy this idea and say that when we are in the back face and we go down, my cat is going crazy. Well, actually the new direction is still down, interestingly. Yes. So we didn't change direction this time because we are appearing from the top. The new face is going to be right face. Then we are going to do this, which we can of course extract, but let's not think about that. And then the new X is going to be, okay, the face X, this remains the same, but now we are basically using the same X coordinate that we had, mod 50, like the same X position in the face, and the Y should change because Y, like Y mod 50 should be 49 right now, but we have to wrap around because we are appearing from the top. So I think like Y should be 0, which is like the same as nothing, or yeah, it's the same thing as if this Y, we continued wrapping around and we appeared at the 0. So we're gonna leave this as this. And let's see what happens. Actually, I want to maybe don't want to print the map now. I want to see if this wrapping got done. I don't know how to go from face right in direction up. Okay, interesting. But we went from back to right in this position to this position. That looks nice. That looks nice. So we did 2 teleportations or 2 wrappings. That's very nice. Let's print the map now and see where we are walking. Okay, look at that. We appeared here and we walked like this. This is kind of weird. I guess we are trying to, yeah, we are turning right. We ended up here. We're turning right and we are going to go this way. I think we are escaping from the right, from the right face. So yeah, it doesn't know how to go from face right in the up direction. And I guess we can think about that too. Now that we have done 2 of these things, I would like to extract at least this to make it a bit less noisy. Extract this into a function. So this is gonna be get cube face position. Yeah, and actually I would like to return this already in map, like in our simulation coordinates. So we are going to do as I32 times 50. And here I'm gonna say, hey, this expectation messages cannot. I would like to say, hey, I couldn't find face. So is there some sort of expect? It's just expect, but map error. This is none, the none case. I think this is what I want, or else it's a function that should return option 32. No, that's not what I want. I want to like say, hey, if this is, well, let's just expect and put some message here. Doesn't really matter. Don't want to think about this. Could not find face in cube map. Okay. And we are gonna do then the same over here. That reduced the noise a little bit. So okay, let's implement this new case and then think about, okay, what is the pattern that we are seeing? We need to then go face right in the up direction. Let's run again and check that we didn't break anything. Oh no, yeah, we did. Index out of bounds. Beautiful. Okay, I know. Where were we? Here, because these things are already, this transformation has already been done. So we don't need this. That's a bit less noise also. And we can run this thing again. Now we should get, yeah, the same error as before. We are over here and we want to go up. Okay, so what happens then? Let's check in the paper. If we go from the right face up, we appear on the bottom of the back face. So here you can see right face up is the bottom of the back face. That's interesting. So that's also implies that the direction won't change. So we're going up this way and we are going to appear down on this way, on this face. Let's implement that. I wonder if I should just keep going doing this until we get an answer, and then after we get the answer we can think of the pattern. So the new direction, well, actually this is not a new direction, but okay, let's say it's up. The new face is going to be back face again, and we are going to appear from the bottom of this. So the X will remain the same. That's interesting. And the Y is going to be, this is interesting, right? Because before we appeared from the left here and from the top here, we never had this case. I think now the Y is going to be like 49, which is well, the face Y plus 49, like on the bottom of this. can express this as like 50 minus 1 if you want to. This is the length of the side. But I think that is correct. And we have to think about what that means as a pattern. So, okay, we went up here. Don't know how to go from face, again, back in direction 1, 2, which is to the right. So where we end up, okay, we appear here from the bottom. We went up, then right, then turned left, then turned right, then turned left again, it seems. Did we advance just one? And we ended here? That's weird. We're turning right, but yes, there was an advance one. Interesting. So we advanced one here, then we turned right, and we are going out this way. Okay, so if we check that, we are on the back face, and we go right, we appear on the bottom of the down face. Now, that's going to be interesting, I think. Here you can see back face. When I go right, which is this direction, we appear on the bottom of the down face. So we appear in this direction, which is the bottom of the down face. And the down face is this face right here. So we are going to be appearing over here. We are going out here, and we are appearing here. Interesting. So let's code that one too, because that's sort of an interesting rotation, I think, and may help us realize what the hell is going on. Going right, and we are appearing from the bottom, so the new direction is going to be up. The new face is going to be the down face. So we're going over here, and we are appearing here, like this one is the down face. Okay, and then if you're on the bottom, the X is going to be the Y coordinate, mod 50, and the X is going to be, well, this is the bottom. So again, it is this like 50 minus 1. I think I sort of know what pattern. Starting to realize something like we can probably do the wrapping before and then use. Sorry, I went way up. Here we are doing we are trying to advance into the. And I think we can maybe use this new X and new Y for instead of XY in these calculations. But I have to think about that. Where was I? I think I just coded this case and we haven't checked it yet, right? I don't know how to go. Yes, from face down in direction right. So look at this. We went over here and we appeared here. That's interesting. We bumped into here, and I guess we turned right probably a couple of times, or we advanced but we couldn't. So now we are going out again in this direction, and if I check the cube, that will lead us to, oh, very interestingly, that's a very, this one is a very interesting case actually. Wow. Okay. Look at this. If we go from the down face to the right direction, I don't know if that appears flipped in the webcam. So you're going right, and we appear on the right face, but totally like upside down. We're appearing from the, well, we see it as the left, but this is totally upside down. So it is actually the right of the right hand face. That's very interesting. And we went a bit to the bottom of this face, and we will appear a bit to the top right. We are appearing basically over here. Very interesting. Let's try to code that. We are going then from the down face in the right direction. We are appearing the right face from the right, so we are going to be going left. And the Y position will be like flipped. That will be interesting. So this is an interesting case where we are changing right, going right to left. This is the first time that we saw this. And the X position is actually going to stay the same, I think. I mean, relative to this face, because we are going to the right and appearing on the right hand side, going out of the right, and we are appearing on the right hand side of the sorry, I didn't assign this. We're going, this is the right face, and we are being on the right of the right face. So the X is going to stay the same relative to the face. The Y, however, is going to be like flipped. If it was near the bottom, it will turn near the top. How do we express that? Well, we have, let's do Y mod 50. If we make the negative out of this, will that work? Will that work? Okay, let's think. Like, if we were going down at 49, this should be appearing at 0. If we were going out at like in the middle, like in 25, I guess, we would be appearing in 25 or 24, something like that. So this is a very simple math operation, but I'm having trouble thinking. What are we doing? Like, if we subtract 50 from Y, we make it point to the other direction. Like mod 50. We can maybe flip this. And then we add 50. I think if we flip this, okay, like if we flip this, if we do 50 minus this, I think that is, like, if this was, well, no, if this was 0, this would be 50. If this was 49, this would be 1 and it should be 0. So I think it's that minus 1. I guess I could do 49, but is this correct? Let's run here. We are going, let's count maybe. We are going right in this direction, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9. We should appear at the 9th row, but from the top. So let's see. Okay, we went there. We appeared here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. 3, 4, 5, 6. It's difficult to count. This is 3, 6. Yeah, this is 9. Okay, so we appeared here. We went up. We bumped here, and then we are turning right. This is interesting. We are going out the same phase that we came in, so we can have this. Actually, it's following this thing in this way. We are noticing a lot of different cases, which is really interesting. We are here. We went from down, going right. We appeared in the right phase, going left, and now we are going to do sort of the inverse case, which is starting from the right phase, going right. We should appear on the down phase, going left, if I'm not mistaken, right? This should be, here we are on the right, we go right. The new phase, yeah, the new phase is the down phase, and we appear on the right hand side. Like, look at this. We are on the right phase. We go right. We appear on the down phase. It's upside down, so this is the right side of the down phase. So the new phase will be down, and we will be appearing from the right. So the new direction will be left. Actually, that's interesting. We go right in both cases, we appear left in both cases. These are kind of the opposite. And similarly, the X will happen the same way, and I think also the Y will get flipped. So we were going out, we bumped here, we are turning right, so we should appear on the second to last from here. So we should appear here, if I'm not mistaken. So let's leave that code. It's interesting how that one was kind of a 180 degrees. I shouldn't have run that in that console. Let's run it here. Woof, there's a lot more going on here. What the hell is happening? So we did appear here, it seems. But then, what happened? Like, where did we end up? Go from face back in the direction up? No, this is direction left. So we are somewhere over here. I don't find the X. Maybe I should have put some color in there, but we are doing a lot of walking. If we don't make any mistake, maybe we can continue doing this very manually and get to an answer. Like, it seems like at some point we appeared here on the second from the bottom, so that was fine, I guess. And we made some other turns. At some point we went, like, did we have some way of going back to the back phase? No, not really. How did we end up here again? Right? How did we? Because we are not walking here from any, like, from the 2D map, I don't think. That's very interesting. You know what? I want to draw the markings correctly. So let's actually copy this stuff. Let's print map. Yeah, the markings, you're gonna do this. So if it's right, we're gonna say this. If it's down, we're gonna say V. If it's left, we're gonna say less than, and if it's up, we're gonna say hat. And you don't like this because you probably have, yeah, something like that. No worries. Beautiful. Not really beautiful. I should learn what is the idiomatic way of doing this kind of thing. Like, should I put the reference here? That seems maybe better. But anyway, let's run now. Woohoo! Look at that, we have directions. That's nice. And we are going from the back face in direction -1. So look at that, it's so chaotic. So chaotic. We went this way, we walked some more over here. This is super interesting, but I don't know, how did we get back into the back face? The only way that we know how to go to the back face is from the up face. So did we? But we didn't walk into the up face. Huh, that's kind of suspicious, to be honest. Where did we, oh, here we are, actually. We can maybe follow this path along. Yeah. Okay, here we could have come from different directions. It seems like we did this. Wow, this is so messy. There's different ways. Oh, did we come? This is the way we came originally, I think. And we did something like this, like this, like this, like this, and we went down, I think. Then are we coming up again from when we went down from the back face, we went down into the right face. Oh yes, we did have a way of coming back. I had forgotten, and I wasn't seeing that this B was also here. Okay, got confused for a second. So this seems to be correct. We ended up here, and I guess we are turning left, and we are going left in this way. You know what? I will continue doing this. I don't know if there is, like, how many more ways of exiting this queue there are. This is quite horrible, but I think if I push along and get to an answer, and very, very hopefully, I don't have such high hopes, we get the right answer, then we can refactor this into like something that makes more sense, knowing that we got to the right place. So we are then on the back face, and we are exiting to the left. So we are, where are we? Where's the X? Well, it was somewhere around here, you know? I am a bit blind. Should I use color? I refuse to. But maybe I could change the printing. This X, let's, oh, is there like a solid black square? I want that. Unicode solid black square. Yes, give me black large square. This looks like double width. I don't want something that messes my terminal. This seems good enough. Let's run. And also we are printing quite a bit, like it's taken some time to print, so we are processing quite a few instructions. Yeah, now it's much easier to see. Okay, we are here. We are going left from here, and where do we appear? So the back side, we go left, we appear on the top of the upside, which I think is the inverse of what we did the first time. So we are going left here, and you can see it appears on the top of the upside. And we are going to the left near the top of this face, and we should appear on the top near the left of the upside of the up side of the cube. So we should appear somewhere over here. That's very good. Let's code that. Where's my ugly switch statement? Let's copy one more of this. So now we are on the back face, exiting left. We're gonna appear from the top, so we are going to be going down on the up face, and the new face X, and the new X, sorry, it's gonna be this plus the Y mod 50. The new Y is gonna be 0, basically, right? Yeah, we can say face Y, but we're exiting through the left, so this should be 0. Yeah. Okay. Let's close this tab. Let's rerun this. Look at it go. Oh, there is so much stuff now. So many breadcrumbs on the map. It's kind of a mess. Where are we? In which face? From the face up in direction left. So we are over here. Look at that. We did this path. We are walking along here, and for some reason we stay there. I don't know what happened there. Like, there is space. Maybe it turned left and then it turns right again. Yeah, it seems like it. Here it turned left, it bumped, and then it's turning right and exiting the up face through the left side and near the bottom. This will be, again, this is one of those 180 turns. The up face going to the left is going to appear on the left face, totally upside down, so it appears on the left of the left face. It changes direction 180 degrees. So if we are on the up face and we go left, our new direction is going to be right. Yes, and we exited near the bottom and we appear near the top. And the new face is going to be left. We haven't been on the left face. Oh, I don't know what. I took a screenshot apparently. Okay. The left face is this one, and I think that's yeah, that hasn't been touched by our random walking, or maybe it did a bit here, but then we went away. So we are exiting near the bottom. We should be appearing here near the top. Left going right. The X should stay the same. And now the Y is the one that should get flipped. So we are gonna copy one of these things. So we have done this like flipping Y's, but I don't think we had done the same thing for the horizontal coordinate for X. That this kind of weird flipping thing. And I wonder if we're gonna have to deal with that. But let's run this. Look at it go. Okay. We just got here, and I think we are turning left and going up again, right? Yeah, turn left, and we're exiting, yeah, from left in the up direction. That was a very short visit to the left face. So we're gonna be coding this case, left going up. And now, where does that leave us? I would like to maybe count how many of this, because we have already implemented quite a few. But let's see first. If we go from left up, we appear on the front face. So here you can see left up is going to be front face to the left. That's interesting. So this is, we appear on the left side of this, so we are going to be going right direction. That's correct. And the new face is the front face. And now this is a like 90-degree rotation. Let's think. The new X, since we are appearing from here from the right, the new X is, we don't need to add anything, it's the face X. And the new Y is gonna be the X mod 50. Okay, so we already have a lot of cases. How many more should we expect? So that's basically going to be equal to, I think, the number of sides on this unfolded queue. So it's going to be 3 for R, 3 cases going from right to top, right and down. We're going up, right and down. 2 for this, so 3 plus 2 is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Counting in English is not my forte. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Am I counting correctly? I don't know. I'm feeling a bit dumb. So how many cases have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9 cases. Maybe this doesn't cover all the cases because there's no guarantee that we are going to be exiting everything from every possible side. So we are advancing even more. Oh, look at this path now tracing. Oh, we ended up here. I guess we are turning right and exiting from here. Right? Did we turn right? Yes. So we are in the left face going left. Okay. So we're going to code left face going left. There should only be a couple of, so we were at, I think, 9 or 10 cases. So, and the total was like something like 14. So we are close. I don't know if I've, like all of this ad hoc math, I'm not confident about this, like if we are actually tracing the correct paths, but at least we are covering, like we are thinking about this thing. Anyway, here exiting the left side to the left, we appear This is an interesting one. It's gonna flip again. Left, going left, is gonna appear on the upside down. So we appear on the left of the up face. Okay, so since it appears on the left of the up face, it's going to be going right, and this is going to be the up face. The X is gonna remain the same because we are on the leftmost part, and the Y should flip. So again, I'm going to trust this. We can, whoops, this flipping code. Where we are here, we are more near to the bottom of this face. We should appear on the up face than kind of near to the top. So okay, let's run this. And it goes, and it goes. Now it's processing quite a bit of instructions. Okay, apparently well, this is a mess now. So much walking around. Did we appear here? I wonder. Like when we exited, I think we were over here. Let's see. This is the bottom row of this face. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We exited at the 12th row from the bottom. Did we appear here at the 12th from the top? 1, 2, here. Here's the top row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we appeared here. It seemed we went down, and then we exited left again. This should then mean that we appeared here somewhere. Well, I don't even know at this point. Where it is, it's not this one. But we have already done like from top the up face to the left, right? That is the case that we appear on the left face, right? So from up to left. Now we appear on the left face facing right. Okay. This makes sense. Let's continue. We are in the right face going down. So we are over here and we're gonna go down this way. Interesting. Let's see what that leads us. That will take us to the front face, which is this one over here on the right side of the front face. So right face going down, face going down will appear on the front face at the right hand side. So we are going to be going left, and it's gonna be, well, this is gonna be an interesting one, I think. The X position, now the X position is gonna be 49. How were we expressing? I have something with my mouse scroll that sometimes jumps to places. How did we yeah, we were doing something like this. So now we're appearing from the right hand side of a face, so we are facing left, and I think that's the Your faces. I wonder something, like here we are going to the left. Why in this case that we were going to the left? This is doing the mod 50. Is there any reason for that? It probably is. It depends on where you're coming from. So this one was going right from the right. Yeah, because x mod 50 in that case, in this case, x mod 50 is 49. And in this case, it's not. But since we are going down here, it would be the same thing as putting like y mod 50 over here without the -1. So that's also an interesting pattern, I guess we can think about. So we are going right, down, we appear on left. This is the new x, okay, sure. And the new y is relative, like it's x mod 50, if I didn't screw it up. Let's go. It's printing a lot of stuff and it's taking more time to reach a new condition. And the map is becoming so messy with breadcrumbs. Really, really nice. Okay, so we are on the front face and we are going left. That's a new one. So the front face is this one. Yeah, we are here and we're going left. Let's think about that. So we should appear here, front face, going left. We appear on the left face on the top side of that. Okay. So let's code that. We should be near covering all the cases. Front face going left will appear at, what did I say? Left face from the top. So we are going to be going down, not down, down. And now let's think. The x is going to be the y of before, so this actually is the same. I think this is correct. And the y should be 0, which actually is the same as x mod 50, so that is the same. Interesting. I can probably leave that pattern. Look at it go. Okay, we are going from front face direction right. Man, there's so many cases. This is the front face. Where are we in this? Here we are. With all the breadcrumbs, it's now even becoming difficult to see this character. So this, we are going right. And this should appear on the right face, on the bottom of the right face. Like this is the right face on the bottom here, like do something like this. Okay, front face going right. So, oh, the previous one was front face going left. So now it's front face going right. The new face then is going to be the right face. And we appear from the bottom of it. So we are going up. And the new x is again the y of this, pretty sure. And the new y is 49, because we are appearing on the downside of this. But if we went to the right, then x mod 50 should be 49. So, you know, this pattern has hold for the last 3 cases. Interesting. Let's run again. I wonder if I have already covered all cases. Let's see. This is probably the most boring video ever, because I'm just doing very manual work instead of thinking a bit more. And I can feel that we are very near the end, at least in covering these cases, because yeah, we counted there should be like 14, and maybe this problem covers all the cases. So going from face down in direction, this is direction, now it's difficult to think, down, right? So the down face is this one, and yeah, we are over here. This will connect to this. I can see it now on the map. Like, yeah, it connects to the back face. So it's going to go from here exactly to here, if I'm not mistaken. Yeah, this connects to this and this connects to this. Okay, so what did we say? Down face going down. Down face going down. We are going to appear at the back face from the right side, so we're going to be going left. And the x position of this is 49, so we can use y mod 50. And the y position, yeah, it's the x of before, so this pattern still holds. Very interesting. Let's run again. Did we now cover all the cases, I wonder? Because we are processing a lot of instructions. Maybe I should turn off the printing to accelerate this at this point. Maybe we have covered all cases, and maybe we will get an answer. And there it goes, we do have an answer. And look at the map, it's a mess. Oh man, it's a mess. We ended up here. So it's a low row, so now the answer is a lower number. I'm so nervous of trying this out, because if it's not the correct answer, debugging this is going to be like impossible. But okay, let's try. Yes, and it is the correct answer. Oh yes. I'm so glad that I didn't make a mistake typing this shit, because it's a mess. Very, very nice. Okay. So, yeah, I cannot believe this was such a hard challenge, such a hard problem. Whew. So we do get the answer. Okay, maybe we can do some cleaning. I want to eat something for lunch, but yeah, we got the correct answer. That's really awesome. I actually want to clean up the printing. You know what? I'm going to comment it, not remove it, because maybe if I want to refactor this into something better, I will need the debug printing again. Okay, so we can have that. And if we run now without the printing, it actually runs very fast. You can see how long it took, like seconds and seconds to run before with the debug printing, but now it runs just in 11 milliseconds, no problem, like almost like instantly. And we are still doing all of this breadcrumb thing. We are inserting all the breadcrumbs, so all the hashing and all of that is being done. Computers are so fast. Okay, look at this beautiful switch statement. This can go. And also Rust helping us, saying, hey, the new phase, you are assigning this everywhere. So that's awesome. Did we actually code so many patterns? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So we had all the different cases. That's really good. That's really good. Okay. Yeah. This is quite nice. I would actually like to commit it as like at least temporarily. I don't want to screw something up and lose these changes. They 22 part 2 solution. Very good. And now maybe we can stare at this code and try to decipher what is the pattern. So let's see, there are some things that I was thinking. When you change direction, so here, for example, this is a simple one. Simple to think about. We were going up and we changed right. So the direction went from up to right. That is like it rotated, the direction rotated 90 degrees to the right. So, sorry, 90 degrees clockwise. And we went to the back face. Let's remember how this is on the cube. Okay. Yeah, we are appearing on the left side of the back face. I guess we can leave this pattern because we were using this pattern down a lot. So actually, that's a length. Yeah. So we were going up and we appeared on the left of the back side. And in terms of position, like for the direction, this is like turning clockwise. In terms of position, well, in terms of position, it's not like a rotation, because if we think like we are going up, and let's say in the left, near the left of the top side, this would be like a low x coordinate and 0 y coordinate, and we appear here on the back side near the top, like on the left side near the top. But that is like not a rotation from the previous position, at least not a rotation on the side of the cube. But I'm wondering if instead of doing this, we could use like, okay, here we rotated the direction to the right, and if we actually use not the XY positions but the modular, like if we consider the up phase, we go up and consider it sort of wrapping around as we were sort of similar to part 1, but if you consider that you appear here on the bottom, you will be on the bottom near the left. And then that's, you know, the position that you appear on the backside is a rotation of that, considering the rotation like from the center of the face. I wonder if that is true for all the other cases, and that would be a 90-degree rotation to the right, the same kind of rotation that we did on the direction. So that's interesting. Let's check. Oh, here we have a case that keeps going down. So let's analyze that case. So we are on the back side. We go down, and this appears on the right side, on the top. So the x coordinates within the face remains the same, and we could actually think, yeah, if we, here we are going down, yeah, if we do our current x plus 1, sorry, our current y plus 1, because we are going down, x plus the direction down, mod 50, we would be appearing here. So that will, yeah. I think I'm starting to see a little bit of a pattern. So we do have the solution. Oh, what happened with the terminal? Hello, terminal. Are you alive? Okay. We do have this 12462. Man, that was so nice to have a solution for this. Oh, look at the drawing here. We have some parentheses. We have some closing parentheses, which I don't know what are the opening parentheses. This to a Lisp brain, that is very obscene. Okay, we have this answer. So I do wonder if instead of using xy, we could have something like, let's say, we can say x, this is basically new x and new y. I want these things mod 50. We might want to say, well, let's say mod x, or yeah, x mod is new x mod 50, and we're gonna have the same thing for y. Okay. Yes, indeed. And here, does it make sense to what was I thinking then? So in the case of up going up, we appear in the back. Yeah. Now these things, for example, in this case that we went up, this thing. Actually, I don't know if I want to like write it explicitly here. This is x plus dx, and this is y plus dy. Yeah. This thing will have wrapped around if we were going up on the up face, and will be now 49. Which, if we do a rotation, when we go to the right hand side, no, sorry, we were going to the back side, yeah, if we rotate that 90 degrees to the right, so we have, what do we have? let's consider that we are standing this. We rotate this 90 degrees to the right. That should be our new x, new y, I think, for this case. So let's try it. Let's say new x, new y is x mod, y mod. We want to rotate this to the right. But we don't want to rotate this to the right from the 0 coordinate. We want to rotate this from the middle of the cube coordinate. So I think we want to do something like minus 25 in each of those, and the result, and then add 25 to the result, something like that. So let's. My brain is a little bit melted already, so let's remember, how do we turn right? We turn right like this, doing minus y and x. So let's actually do something like, say, can extract this to turn right, I guess. It doesn't make a whole lot of sense. I guess we could. We would be passing, yeah, an xy coordinate. So, yeah, dx dy. Generate this thing. We're gonna return just simply this. Very, very stupid code, but let's roll with this. We can have the same thing for turning left. This is in part 2, okay. Turn left. It's gonna be the same, but we're gonna leave the y here and we're gonna use minus for the x, okay. And again, I am refactoring things, unrelated things. I have this bad tendency, dx dy, like, I don't know why I do this. Yeah, let's revert those changes. Let's leave that in there. Let's see if we still get the same answer. Yes, we do. Okay, now let's redo here. Now we want to turn right, but in the direction of the cube. Sorry, in the face of the cube. So, and this is hard to think of. Maybe I even want, before doing that, I want some printing. I want a printout of what the hell. This is new x and new y. Okay, let's print this case. Println went from up to back, and we're gonna have x and y, and this converted to new x, new y. Okay. Yeah, we did this quite a few times. Actually, we can do maybe the new calculation to see if it's the same as doing this new x and y. So we will have this. Let's have a constant. Let's copy these functions. We're gonna have very similar functions, but called, well, we don't need the left one yet. turn right in face, and let's have a const cube or face side. It's going to be 50. I wonder if this should be a U size or an A32. We can decide that later, depending on how many. Yeah, it's probably going to want to be, well, I actually don't know, because we are using it in many places. I wanted to define the constant now because I want to do this like divided by 2, and I will use 25, I guess. So turn right in face. What we want to do then is to say, hey, turn right this minus face side divided by 2, this minus face side divided by 2. What's happening? Like, it's indexing something. I'm getting distracted by this thing. Something is working, but I don't know why it is. Yeah. Come on, editor, stop being annoying. So yeah, here we are translating this, like seeing this position from the center of the cube, and then we have to transpose it again. So we're gonna add 25 to both things. So let's, I don't know, new x, new y is this, and we'll return new x plus face side divided by 2, and new y plus face side divided by 2. Okay. And here, I guess we can do yeah, this x mod and y mod is basically the position in the face wrapping around in the direction that we came. This is very distracting. I'm going to close the editor and reopen it because, hell, that was distracting. Okay, hopefully it will stop doing that. Also not resume doing that. You have deprecated extensions. Yeah, okay. Don't bother me. Yeah, we want to see if rotating these things to the right give us the same new x and new y. So let's say let's, I don't know, x2 and y2 equals rotate or turn right in face the mod or the x mod and y mod, and let's just print if these things are equal. Are equal? Let's say new x new y is equal to x2 y2, and let's see if this computation cargo round 22. No, they are not equal. Okay, let's print them then. Let's say or x2 y2. Okay, let's run now. Oh, because we haven't translated with the face coordinates, that is something. But 51 is not a number that I want to see. Maybe we need to mod again. Huh, interesting. But okay, the 8 plus 150 will be that. But why 51? It went from 58.0 to 158. 0, 158. Wait, is this the I don't know if this rotation makes a lot of sense. Let's try to first see if that's actually what we want. So yeah, before anything, let's just print rotate turn 0, 0 right, like in phase. We are going to do turn right in phase of 0, 0. This should be 49, 0. And I think, yeah, now we have a problem. Okay. Yeah. This is because we are subtracting 25. Like, let's see what happens. Here, we are turning right. We are subtracting 25, so we have minus 25, minus 25. Then that thing rotated to the right should be 25 minus 25. Maybe I can have these functions close together. Okay, let's clean something. So minus 25 minus 25 turning right is going to be 25, yeah, minus 25. And then that thing, we should translate it back. Interesting. So there's something that I'm doing wrong, but I'm not seeing it. Should I be subtracting -1 from all of this, I wonder? Well, let's... No, not really. Because that would be minus 24, and then we would go to 24 minus 24 when we add that back again. Wait, am I? There's something that I'm really not seeing here. This was supposed to be easy. So yeah, this would be for 0, 0. This would be minus 24 minus 24. When we turn right, it will get converted to 24 minus 24, and then we add this. So this should actually be 48, which is not a great answer. I want this to be 49, but and 0. but I am getting something very stupid here. What the hell? Really? Like, what the hell is happening? let's just the panic here. Wow. Like, wait a second, please. Like, let's panic and let's do more printing, because I'm like println new x new y. Come on, return this. Warnings, warnings. Oh, 26? Oh, yeah, okay. I was thinking the other way around. So now this is not what I want. It would be very stupid to try with +1, but I am kind of not thinking straight, so let's just try it. Okay, so what we want to do for this, like, it seems very weird to me that this should be simple, like turning right inside a face. The x becomes -y. Yeah. So if we are going like this, does make sense. Like the turn right is for sure correct, I think. So yeah, all of these +1s are nonsensical. So this is kind of what I want, except off by 1. So let's think. Okay, this is 0-based coordinates inside the face. If we are at x like, let's think of something that shouldn't rotate. If we are x24 and y24, when we do -25, it will be -1, -1. Okay, let's try that case, maybe. Okay, turn 24, 24. This, I think, should leave us in 25, 24. But it probably won't. 26, 24. So we are getting the y coordinate right, but we are getting one more for the x coordinate. And I wonder why, because what we are doing here is very symmetrical. Because we are rotating at, I think, a wrong middle point, maybe. This should only advance 1, but we went from minus 1, -1 to 1, -1. This one should be relative to, like, yeah, it's like the middle point of the phase is between, like, there is no, since this is an even number, 50, there is no cell that is in the middle and won't rotate, right? So I do wonder if there's a much simpler way of expressing this. What if we do something like, hey, this is the coordinate in this phase. I rotate the coordinates, rotate the initial xy's, and then transpose. I don't think that makes a lot of sense. Maybe it does. So if you think of the xy should always, I think, be a number between 0 and 49. So when we rotate this to the right, I'm sort of imagining this, well, in the coordinate space of this drawing, like being xy from 0 to 49 means, like, in an xy normal diagram, it would be on the right down coordinate, and then when we rotate that to the right, we are going to be like on the third quadrant, I think. And I think then if we just add 50 in the x direction, I think that will be the same. Let's maybe try that. Have no idea. I'm gonna do this and then just return x plus face side and y. Like, this doesn't make a whole lot of sense, but let's think a little bit. X and y are between 0 and 49. So they are both positive. When we turn them right, we are negating the y coordinate and we are putting that on the x. So yes, when then we add the face side, this will be again positive and this will be fine. This actually makes more sense. And what I was doing was pretty stupid. I'm still not getting the correct answer, but I'm getting the same answer as before. So this is equivalent as what I was doing before. So I think it's not face side what I need to add. It is face side minus 1, 49. Why? Because, well, I don't know. If we rotate, yeah, 0, 0, yeah, we want this the 0 to end at 49. Okay, let's try like this. This should give me the right answer. Yes, it does. Let's try it with the 4 corners of a face. So turning 0, 49 to the right, turning 49, 49 to the right. Okay, and then turning 49, 0 to the right. Okay, let's run. Okay, so turning 0, 0 is x49, yeah, y0, that makes sense. Then 049, yeah, I should have started here from this, but okay. This is like going down, like bottom left, it becomes 0, 0, that makes sense. This is bottom right, it becomes bottom left, makes sense. And this is top right, it becomes, yeah, bottom right. Yeah, this makes sense now. Okay, we are rotating in the face correctly. Who needs unit tests? Okay. I can probably close, I don't know why I was using that side panel all the time. Let's clean things a little bit. And now turning right in face is now equal to what we were doing. Well, no, but now it's because we are not adding the face X and face Y. But I think that if we add that, they are going to be equal. So let's say just have let x3 and y3 best name server. It's going to be x2 plus face x and y2 plus y face. No, not what y mod, y face. Sorry, face y. Okay, then I should be comparing these two, x3, y3, and x3 and y3. They are still not equal, but how do they differ? Here we are we are ended up at 50. We are doing we are passing in the mod 50, okay. Oh, I wonder to do this mod 50 if we would need to, so let's remember here the app. Yeah, I think this is negative. We were in the up phase going up, so y is 0, so then y plus dy is going to be -1, and this mod 50 is -1. This is not what we want, so let's add 50 over here to do to have the mod be always a positive number between 0 and 49, which I think is the same as calling the method rem Euclid with 50. Now let's try with this now, and now they are the same. Okay, very good. So I guess if we don't want to do this like this, we can say something like rem Euclid with 50. Is this the same? Yes, it is. Okay. Okay, so it is like turning right in face. This is the same as doing new x, new y. Now this plus the face x, face y. Yes. Okay. Okay. So new x, we can say no let here. new x plus equals face x, and new y plus equals face y, something like this. If we run, we still get the same answer. Okay, very good. Those printouts, I don't know what they are. Prints. We are what printing is this? Oh, these ones. Okay. X and y should be in 0 up to 49, or 0 to face side. Yeah. So okay, I wonder, well, if we can keep this kind of pattern, right? Then when we are doing this, we are basically turning 0. If I, okay, let's say here we are adding this x. This is the same as x mod, and the y, we were going down on a face and reappearing on the top, so this should be, I think, the same as y mod, and we did like 0 rotations. That's right. Yeah, we get the same, and we did 0 rotations. Turn right in face. Okay. Here we are going up on the right, and we keep going up. So again, this is x mod, and this 50 minus 1, I wonder, is it just y mod? Yes, yes, yes. Okay, so we are seeing the pattern, I think. Same thing here. Oh no, here it is a rotation. So we were going right, and we ended up. This would be a rotation left. We could think of this as a rotation left, but we can also think it as 3 rotations right. So I think I may want to try that, like rotating it 3 times to the right. And here we have this. This is like 0 rotations. Okay, so let's write it like as a loop. We're gonna do so for in 1 to 0 to 3, 0, 1, 2, yeah, 3 times. We're gonna do this, turning right Oh, but the new x, new y should... Okay. Y mod. Yeah, I'm pretty sure that in the end I will be using new x and new y for this, but in the meantime, let's do something like temp x, temp y is like, come on, we want to start from x mod and y mod, and then changing that. So I guess we can do new x, new y, be x mod and y mod. And then we are going to rotate itself this number of times, new x, new y, like 3 times, so it rotates to the left. And then we are going to basically just add the face x and face y. Which is, and here in these 2 cases where we continue going the same way, it's like having this loop but looping 0 times. Right? I think. Let's try. Let's try to run this now. And it's the same number. Okay, okay, okay. It does seem legit to me. I don't know if I need to test other cases. Maybe this. Oh, this is a 180-degree rotation. So what if we do like copy this loop? Like, let's copy all of this into here and just do 2 rotations, right? Unexpected character. Oh, I think we copied, I don't know what we copied. Let's try again. Oh, sorry. Control C, come on. Left, right, and left, okay. And let's not think and try to do this. Like, if it makes sense. Yeah, we're going off the right. The new right is this. We are appearing, like we're going left, so we are appearing from the right of this. If we do 2 rotations and then we do the same as before, does this still? Yes, it does. Okay, so I am now a bit more confident of what we need to do. Actually, we can even think of the destination phase and the destination direction, and that's it, instead of thinking it in amounts of rotations. So if we are going up and then the direction is going to be right, we can try rotating the up direction until it is different. Sorry, until it is right. So that is the amount of rotations that we have to apply, I think. Okay. So yeah, let's try to express it like that, and I am more or less confident. So let's say what? New phase and new direction, which is this new dy new dx, new dx, new dy. Actually, this we would be doing something like this, I think. So the app will be the tuple. So this first case will be the tuple b and right. And all of this should go away. We can put a semicolon here, and this got reduced to this. Okay. Actually, we don't need to, well, this new phase can go away. And let's replace then. I guess we can even try to do, yeah, we can try to do a mass replace of this. We're gonna have something like this. Sorry, so we want to be here. Let's do open this, put this character, comma, space, this, and that's it. That's what we want. So we want that, and I guess we want to get rid of all the lines that follow this. But it's going to be a different amount of lines in each case. But I think, yeah. Okay. So if I didn't screw up, this should be the sort of mapping that we have. And now we have to do the rotations of the new directions. Actually, the new direction is already assigned, so that is really good. New dx, yes. New dy. Let's call this thing new dir and use this new dir to assign, because we are then returning this thing over here. So let's assign new dx and new dy here to new dir. And then we want to replicate what we were doing before. We're gonna rotate x mod and y mod the amount of times it takes to rotate this into this. Okay? So we can say something like, while, let's have a variable, I guess. Let's there be our initial dx, dy. This is going to be a mutable thing. Well, this direction is different than the new direction. Okay. While it is different, so for cases that it doesn't change, this while will not be executed. that is sort of important, I think, because that means, like, okay, the these things, we can move this over here. Let's do this over here, like the updating of the outside variables. We're gonna have this. This is x mod. Yeah, we're gonna want to have variables for this. I guess we can use new dx and new dy for this, although it's a bit messy. We can also use this. Yeah, I guess we could use this. And we're gonna rotate x mod and y mod, and then, yeah, and then assign that. Yeah. So what we are going to do is x mod, y mod, turn right, turn right in phase x mod, y mod. Okay, you're happy with that, but we also have to change the direction, and the direction is turn right of this direction that we have right now. So it would be the 0 and the 1, x and y. Okay, and when it is equal to the new direction, we have rotated the positions. And finally, we are going to assign new x is going to be it's going to be phase x, which we lost. Yeah, because that calculation, we can do it here. Let phase x and phase y be get q phase position for the new phase, right? Yeah. So new x is going to be phase x plus x mod, and the same thing for y. Okay. New phase, why do you complain? And use variable. Huh. But I'm using you right here. There's also get cube. Oh, I hadn't saved. Okay. Is this all that we want? Will this run? Print map is not being used. Oh, and look at that. It actually ran, and we had the same answer as before. That's really cool. That's really nice. So yeah, all the huge match statement that we had before now has been reduced to this quite nice mapping, I would say, of, okay, we are escaping the up phase going up, then we appear at the back phase going right. And that's quite nice. Very nice. I think one, I'm thinking about the variable names here and this kind of thing, but yeah, this is much better than what we had before. We can probably compare. Well, turn left and turn right used there. That's not much of a difference, but now we have all of this reduced to that little thing and this calculation. So that is much nicer. Yeah, like minus 50 lines or something. It's still quite a long advent of code solution, but yeah, I'm pretty happy with having found this solution actually. There's probably things that could be improved, sure, but I think I am quite happy with this. I'm now going to let's see. Yeah, clean some of the printing, or the commented printing, I should say. It's a very chaotic also, like part 1, part 2. Yeah, the code between part 1 and part 2 is pretty repeated and like chaotic separation, but I will not try to be merging those two now because I'm quite hungry and I want to eat something. But I'm quite happy with how this turned out, I think. Yeah, is there any more printing? No. So yeah, this is pretty nice. This is quite nice. This could be improved. I'm sure some of this could be improved too, because here in the end what we are doing here is like warping around, and it's like, okay, these are kind of two different cases. But okay, I think it's fine. And the runtime, I think it was also quite decent, right? Yeah, if we run it in release mode, it's probably some couple of milliseconds. Yeah, 1 millisecond. No problem. So the runtime is not really problematic here at all. Even this thing that we are iterating here and we could pre-compute is no problem at all. And actually, we can get rid of breadcrumbs too. Yeah, because these breadcrumbs are only being used for were only being used for the printing of the map. So now they should not be used, and we don't need this import. So that's also nice. We shouldn't need this debug. Does it still work? It should. Yeah, now it's less than 1 millisecond. So yeah, this is pretty nice. The code is a bit messy in terms of organization, but I'm quite happy with this result. So let's commit. Day 22. No, actually, I don't want to commit. I want to amend a previous commit. So aborting, yeah. Git amend, or let's say commit amend. The message, well, yes, the message is fine. Okay, so I think that will be it for today. We managed to find a solution to part 2. It's not a generic solution, so it doesn't work for any input. It only works for my unfolding of the cube, which is expressed in where? In this mapping. Like this contains the information that is like hard-coded for, well, I guess this and all of this. So a real solution for this, I guess now the test would be broken, right? So if I do cargo test, yes, it fails because yeah, it's complaining. So, but the problem is that the test won't work for the sample case. The cube. Actually, I can maybe replace the. Is there any other 50? Yeah. We can replace that 50 by the face side. Let's say this is probably going to complain with because not being usize, but I guess we can put as usize in here. Okay. Okay, and did we have any other 50? Yes, in there. So these two 50s are also face side. I guess it's face side could call cube size. Yeah, cube size. Yeah, that makes more sense. And in the sample, like this shouldn't even be a constant actually. What we could try to do here in this function for part 2, we could actually maybe, yeah, we can say something like okay, this cube size, face position. Yeah, we can do something like if the map length is, let's say, less than 50, this is the sample case. So we are gonna panic basically. So let's say instead of using a constant for that, we can actually say let cube size be, okay, this is the sample case, and we're gonna panic here because we don't know how to, oh, we can leave it as a to-do maybe, to-do implement generic solution that works for sample input. And else it's 50. Okay, and then we would just use this in the code instead of the constant. Yeah, we can do that probably. So here we can replace this lowercase, sure. And here we should, well, actually also lowercase it, but pass it. So to write in face, it needs to know the cube size. Okay, and here we just pass it along. Cube size, sure. And here also get cube face position. Well, actually, we can avoid this, I guess. Let's just return this as i32. And here we can say face x and face y times the cube size. Okay, so now it's not a hard-coded constant. It will depend, like in the sample size, we need to implement it, but it should be 4. And this will complain because it's an unreached code. I don't know if we can. Put like, hey, don't complain about this, but it should be 4. And this is basically, this condition is if the same thing is the sample. Okay, so we can say, hey, if it is sample, you're gonna do this. right? We can even move this. If is sample, we complain, and otherwise it's just gonna be like this. And if we have a generic algorithm, this should work. Okay, so we run the test. It should be not yet implemented, implement generic solution, blah, blah, blah. Yeah. And if we run for day 22, we should get, yeah, the same answers that we had before. So that's nice. And well, we have a failing test, basically. I don't know if this test adds a lot of value, but I'm going to leave it and just, well, let's commit this the hard code cube size constant. Okay. I think that will be it for this video. If you have been watching so far, I hope you enjoyed some of this. I think it was probably very boring solution, but it was actually quite challenging. I think this is the hardest, or one of the hardest advent of code problems that I solved, and I didn't even solve it like correctly. But I can think about that later. And well, I will also hope that the next 23, 24, and 25 problems are not as hard as this, but maybe they will. So yeah, that's it for today. See you next time. Bye bye.